Hey guys, today we're going to be talking about the distributive property. Now, the distributive property is used a lot in high school mathematics. It's something you're going to be running into on a very regular basis in pretty much every class you'll take pre-algebra and on. So it's important for us to understand what it is and why we use it. So I'm going to start with something that probably seems pretty straightforward, but I believe is critical to understanding why we use the distributive property. Let's say we have an expression like this. 3, and then in parentheses, 2 plus 4. Now I think when most of us would look at an expression like this, we would follow the order of operations, right? Order of operations tells us combine our terms in the parentheses or solve what's in the parentheses. That would get us a 6 in there, right? And then we would go ahead and do the multiplication that is involved with this 3 on the outside. 3 times 6, and that would give us 18. Now, I think that's what most of us would do if we were faced with this exact expression. However, mathematics poses the question, what if we cannot combine these two terms? What if we just have an x on one of them, say, 2x and 4? And from what you know about combining like terms, those two numbers can't go together. So can we just not do anything with the expression at all? This is where the distributive property comes in. The distributive property says, yeah, you would probably go ahead and add those and then multiply by the 3. But you don't have to. There's an alternative way to go about simplifying this problem than our traditional order of operations. The distributive property says you will get the same answer if you multiply this number on the outside by each individual term and then do whatever operation is right there as you would have otherwise. So we're going to test that theory. We're going to test the distributive property, the idea behind it. So again, it says that if we took this equation and instead of adding first and then multiplying, we went ahead and said this number on the outside, this 3, needs to multiply both of them. We're going to do that first, then we'll add. So 3 times 2 is 6, and then 3 times 4 is 12. And then we go ahead and add. We do the operation between them. 6 plus 12 gets us 18, just like we got when first solving the problem using our traditional means. Now, this is a fact that is true regardless, as long as we have a coefficient or a number on the outside of a set of parentheses and we distribute it or multiply it by everything inside the parentheses, we will get the same final answer, the same evaluation as we would if we did the stuff in the parentheses first. So this is really critical whenever we introduce numbers inside these parentheses that have variables on them, like I wrote a little bit ago where I threw an x on that too, right? I'm going to make a whole new example with that. Let's say we have a 5 on the outside and then a 3x plus 2. Now, whenever we look at that and we say we want to do what's in the parentheses first, we want to follow those order of operations, we can't, because these two terms don't mesh together well. They cannot combine because they're fundamentally different. But we still want to do something. We still want to solve as much as possible. So since the distributive property says it's okay to go ahead and multiply that number on the outside by both of them first, we can do that. We can deal with this 5. We can get that 5 put in there so that we have something a little bit simpler to look at, an expression that's a little bit simpler to work with than having all these different numbers. So that's what we're going to do. The 5 is going to multiply the 3x, and the 5 is going to multiply the 2. Now, oftentimes we use the term the 5 will distribute to each of these because it's kind of a synonym with the distributive property. And I think using that term helps all of us remember exactly what we're doing, that we're not just doing multiplication, we're distributing using this property. So you may hear me say that a lot, that a number on the outside of parentheses will distribute. So 5 times 3x, that's going to get us 15x. Because the fact of the matter is, what's happening whenever we multiply a variable, or a term with a variable, times a whole number without a variable, is the coefficients, or the whole numbers, I should probably be saying, are going to multiply. And then any variables there will multiply as well. They kind of happen separately. But in this case, we have two whole numbers, a 3 and a 5. That's going to make 15. And we just have this 1x. It's kind of hanging out on its own, but it stays with the other numbers. So it stays there with the 15, making 15x. Now the 5 will distribute to the 2, and 5 times 2 is 10. You always want to make sure you keep the sign with this second number. It's important for us to remember that this is a positive 2, and if that were a minus sign right here, it would actually be a negative 2 that we're multiplying. Very important to keep your signs straight and just accurate as you solve the problem. So we would be able to rewrite this expression now as 15x plus 10. These two expressions are equivalent. We could test that out, and if you want to test it out yourself, you can. We're not going to do that on the video, but you can test it out by plugging in a number for x in these. If you just chose a random number, say 9, if you plugged in 9 here and evaluated the expression, and you plugged in 9 here and evaluated the expression, we would get the exact same answer. That proves that these are equivalent versions of the expression, especially if you try it with multiple numbers. I suppose that's what proves, if you try it with all sorts of them, but trust me, they're the same. If you have any questions about the distributive property, drop it in a comment below. I'll probably be doing a second video with some more examples of the distributive property and getting some more kind of fun problems with a few more variables and negative signs in there. But yeah, if you have any questions on this, let me know. Otherwise, see you guys later.